Okay, so we want to find the GCF and then write the polynomial in factor form. So we want to figure out what is the GCF of each of these polynomials that we talked about on Tuesday. And then we want to rewrite it so that the GCF is on the outside and we have a factored polynomial. What does GCF stand for?
Greatest common factor.
Greatest common factor. So we're looking for what's that largest possible term that both of these, or all the terms inside that polynomial have in common. So looking at your first one, A, what do these terms of this polynomial have in common? They both have an x in them. Okay. Anything else?
4 and 8 because divided by 2.
They can both be divided by, what was that?
2.
2. So both of these are divisible by 2. Can we get greater than that? They're both divisible by 4. So they both have an x in them. They both are divisible by 4. So we can say 4x would be our greatest common factor. So 4x. All right, so if we factor out 4x, we then want to take that away from each of these terms to write it in their factored form. This is our GCF, now we want to write it in the factored form. So if I were to take 4x squared and factor out 4x, I'm dividing it by 4x in a sense. 4 divided by 4 is just going to cancel out. It's going to be 1. X to the second divided by a single x will just be a single x. Because remember, whenever we divide by variables, you're taking those exponents and you're subtracting them. So 2x's divided by 1x is just going to be a single. And then same thing for the second one. We're taking 8 divided by 4. Alright, turn it off. 8 divided by 4.
Oh, you won't stop.
Freaking ass.
Alright, let's row on.
It's not that,
So 8 divided by 4 is 2. Well, it's negative 8. I'm sorry. Negative 8 divided by 4 is negative 2. And then x divided by x is x to the 0. And so it cancels out. And so it's just x minus 2 and 4x are your two factors of your polynomial. Are we okay with this? With how we did that? Kind of, a little bit. It's been a day. Looking at the second one, what does the second one have in common with all those terms? So there, our greatest common factor of 9, 27, and 81 is 9. Okay, so we know they all have a 9 in them. Anything else? Okay. They all have at least one x. Okay. Can we get greater than that? It's our greatest common factor. Not just a common factor, we want a great common factor. All divisible by 4. 27 and 81, I don't think, or 9 are divisible by 4. They all have an x in them. We said that, right?
Yes.
Yeah.
What's the minimum value of x's in each of these terms?
2.
The lowest one is 2 x's. So actually, rather than just a single x, we can take out an x squared from each of these values. Wow. So we can go even better than just a single x. We're going to take out 2 of them. So 9 divided by 9, just be 1. X to the 4th divided by x to the 2nd will just leave me with 2 x's. Negative 27 divided by 9.
Negative 3.
Negative 3.
I got it out of
No one's home, my mother keeps texting me. I did it earlier.
Thank you. Alright, negative 27 divided by 3 is negative 3. X to the 3rd divided by x to the 2nd will give you just a single x. And then lastly, we have 81 divided by 9 is positive 9. And then x to the 2nd divided by x to the 2nd will cancel out, so we just have 9. So we factored out our GCF. Once again, if you wanted to check just to make sure this was correct, multiply that factor back in. Distribute it back into each of those terms, multiply them together. You should get your same original polynomial. We're just backwards multiplying. We're pulling them apart rather than multiplying them together. Are we okay with this?
Yeah.
Sure. What is the GCF of this polynomial?
2, 3.
4.
What is the GCF of this polynomial?
That would be really
4.
1. So 8 is divisible by 4, but 15 isn't. 15 is divisible by 3, but 8 isn't.
2.
what if it would be all?
1's not a great common factor. 1's a weak common factor. Can we get greater than 1?
No.
Why not?
Why? Essentially do a decimal. Yes.
Do 8 and 15 have any common factors? No. Is there an x in all of our terms?
Yeah.
No, 15 doesn't have an x. We can't pull out an x. Oh, come on. There we go. So we can't pull out an x, and we can't pull out any coefficients. So can we pull out a greatest common factor at all? No, because if 1 is our greatest common factor, and we divide everything by 1, is it going to change? No, it's going to stay the same. So right now, we really don't have a greatest common factor. So we can't really factor this at the moment. So, using our method at the moment, we can't figure out how to factor this any farther. Right now, this is as much as we can factor it at the moment. Have we ever multiplied polynomials together and encountered a polynomial that looks like this before? X squared plus some x plus a constant. We ever multiplied things together and got something like that?
Yeah.
When? Welcome, AJ.
Hello.
Where have you been? Why aren't you here?
And I had to go talk to Paul.
I hope here.
No, I would have been here, but I had to go talk to Paul.
All right. In the past, we've had two binomials, two-term polynomials. X plus some number, x minus some number, something like that. A combination of two of them. How do we multiply these together again? Joey. No, throw things. So we distributed each of those terms of the first one into each term of the second one. So it was x times x, which got us x squared. X times 4, which got us 4x. 3 times x, 3x. And then 3 times 4 is 12. Good. From here, we were able to find our like terms. We have a 4x and a 3x. These are both like terms, so we can combine that together, which is 7x. Good. Does this look similar, or at least the same pattern as the first one? Okay. So, if we are able to figure out what these two factors are of our original question, the question we just had on the last one, then we can factor these. But it's not necessarily a greatest common factor anymore. We have to factor out a whole binomial. It's not just a single term. We have two terms we're trying to factor out at the top. So, we need to find a pattern that can help us determine, okay, what are these, what is it? It's going to be x plus some number and x plus another number. We know are going to be our factors. But we need to find a way that we can figure out what these patterns are, or what these numbers are. So, with our answer, we had two numbers. We had 12 and we had 7. Our original polynomials consisted of an x plus a 3 and an x plus a 4. An x plus a 3 and an x plus a 4. How can we combine 3 and 4 to get 12? Multiply, so we can do 3 times 4. How can we combine 3 and 4 to get 7? Add them. So, there's a pattern that is pretty consistent with these quadratics. So anytime you have this a three-term polynomial, these trinomials, quadratics with the second power, a way we can factor them is if you look at that last number and think, okay, what are two numbers that multiply to get this last number? What are two numbers that add to get my middle number? If you can find two numbers that do both, those are going to be your factors. So in this case, 3 and 4 multiply to get 12. 3 and 4 add together to get 7. Those are our factors, x plus 3 and x plus 4. So coming back to that problem we just had, x squared plus 8x plus 15. We want to try to figure out what are these factors. One way to help you keep track of your information when we go through these problems to try to think, okay, what numbers am I multiplying? What numbers am I looking at for that multiply? What numbers am I looking at that adds? What we're going to do is we're going to create this little x. I'm going to create a little x. In the top of my x, I have 4 little quadrants. In the top of my x, I'm going to put my last number. So that 15 is going to go up there. In the bottom of my x, I'm going to put my middle number. So 8 is going to go right there. Now these other two spaces, I have to think of 2 numbers that multiply together to get 15, and 2 numbers that add together to get 8. So 2 numbers that multiply together to get 15, 2 numbers that add together to get 8. 5 and 3. 5 times 3 equals 15. 5 plus 3 equals 8. So 5 and 3 will be our factors. So now that we have these 2 numbers determined, our factor form is going to be x plus 5 times x plus 3. We can just jump right to that factored form as soon as we figure out what those 2 factors are. Are we okay with this at the moment so far? So think, what are those 2? What 2 numbers multiply to get 15? What 2 numbers add to get 8? All right, let's look at the second one. So once again, last number, 24, goes in the top of my x. Middle number, 11, goes in the bottom. I need to think of 2 numbers that multiply to get 24, add together to get 11. Multiply to get 24, add to get 11. Two numbers that multiply together to get 24, add to get 11. If you have trouble, one thing you can do is you can think, okay, what are some factors of 24? And you can start listing them. Well, I know 1 times 24 works, but that doesn't work. And so you can go through it until you find a pair that can actually add together. So 8 and 3, together they multiply to get 24. If you add them together, you get 11. So this would be x plus 8, x plus 3. If you want to check whether you have the right answer, if you're afraid your numbers aren't right, multiply these back together. Distribute it like what we've done before. And if you get the same solution, if you get what you started with, then you have the right answer. If you get something else, then we either multiplied wrong or our 2 numbers are wrong. If you're someone who has trouble thinking of factors, if you just have trouble like coming up with 2 numbers that multiply, I have some factor multiplication tables just so you can reference, like, okay, I know 24 is here. Okay, so some factors of 24 are 6 and 4, 2 and 12. That way you can start getting, if you have trouble pulling up those factors off the top of my head. So I'll pass these around. You don't have to use these, but they can be beneficial if you have trouble with that. Yeah, it has a teddy bear on it. All right. Once again, these multiplication tables, you're not required to use them. It's just if you have trouble thinking of factors, it's a helpful tool to have. So I'm not saying you have to use this multiplication tool to help you. It just might be beneficial to look at sometimes if you're having trouble thinking of the factors. And I'm sorry they have little teddy bears on them. I couldn't find a better multiplication factor that would be printed out.
Those are pandas. Yeah, Jonathan.
All right, I want you to try. So create that X. Put the last number in the top. the middle number and the bottom and try to think, what are your factors? What are two numbers that multiply to get that number? What are two numbers that add to get that number? See if you can factor these quadratics. Use your multiplication table if you're having trouble thinking of the factors.
I was always fail.
How would you write it? The first one, we need two numbers that multiply to get the last one, two numbers that add to get the number.
It's not. It's not the floor now. Wait, why do you always sit in bed? You always sit around. It's because we always talk around your spot. You can wear that.
Where do you place 12? So we're trying to think of two numbers that multiply to get your last number 3. So 3 times 4 equals 12, 3 plus 4 equals 7. So 6 times 6. What's okay, let's talk about this. All right, Jody, have a seat, please. Have a seat. All right.
I did a lot.
We're just going to keep talking?
Yes.
All right. Look at this first one. We create our x. We have 12 on top, 7 on bottom. Two numbers will multiply to get 12, add to get 7. What do we come up with? 3 and 4. So x plus 3, x plus 4, that would be our two factors. You can jump straight to the x plus 3, x plus 4. What about the second one? We have 32 and 12. So 4 times 8 gives you 32, 4 plus 8 gives you 12. So x plus 4, x plus 8. Once again, if you're having trouble with this If you have trouble thinking of those two factors, those two numbers that multiply together, this is.
It's an ad. They're everywhere these days.
If you have trouble figuring out those factors, look at that multiplication table. Look in the middle. Try to find your last number. So I'm looking for 32. I found 32. Then I look at, okay, what are the two factors of it? 4 and 8. Oh, they add together to get 12. So use that multiplication table if you have trouble. All right. On that last situation, on all the factors we've done so far, all of our numbers were positive. We had a positive 12, we had a positive 7, we had a positive 32, a positive 12. With this, we're seeing what happens if that middle number is negative. When we talk about quadratics, we have 3 letters for them. It's ax squared plus bx plus c. We use a, b, and c to represent the coefficients of each of these terms. So a is the number in front of x squared, b is the number in front of the x, and c is the last number. So anytime I'm talking about quadratics, I'm talking about a, b, or c, I'm going to be talking about one of these terms, one of these coefficients. Right now, looking at our first one, what is a? What's the number in front of that x squared?
1.
Just 1. What would my b be for that second one? For the first one, sorry. Negative 11. And then what would my c be? 24. So, we're going to look, what happens, how is this factoring different if my b, my middle term, how is that factoring different if I have a negative in the middle term rather than having all positives? So we have to think of two numbers that multiply to get 24, but then add to get negative 11. How can I get two numbers that multiply together to get a positive, but add together to get a negative? Two negatives?
Yeah.
Okay. So I need both of these numbers to be negatives. So what are two negatives that multiply to get 24, but add to get negative 11? Negative 8 and negative 3?
Wow.
Good job. So my solution would be x minus 8, x minus 3. So if my b is going to be negative, I'm going to get two negative answers. If my b was positive, I got two positive answers. So same with this one. I need to think of two numbers that multiply to get 8, but add together to get negative 6. Two numbers that multiply to get 8, but add together to get negative 6. So because our b is negative, we know they're both going to be negative numbers. Wait a minute.
Negative 4, negative 2.
Negative 4, negative 2. Together they multiply to get positive 8, but together they add together to get negative 6. Awesome. So our solution will be x minus 4 times x plus or x minus 2. Good. Are we okay with this? So if the b is negative, you just have to remember, oh, both my solutions are going to be negative because I need two negatives to multiply to get a positive, but two negatives to multiply to get, or to add together to get a negative still. Okay. All right. Once again, try to figure out these two. Think, what are your factors? What are the numbers I'm trying to multiply together for? What are the numbers I'm trying to add together for? See if you can come up with these ones. For this first one, what do we find for x squared minus 13x plus 42? So we got negative 7 and negative 6. So that means it would be x minus 7 times x minus 6 is your factor solution. We always want to remember to write it in the factor solution when we're done. What about that second one? X minus 5, x minus 2. Awesome, good. Negative 5 times negative 2 is positive 10. Negative 5 plus negative 2 is negative 7. Good. Still comfortable with this?
Yeah.
It's getting a little bit easier as we start to get more familiar with it.
Yeah, sure.
Cool. All right. One other type of situation. Rather than having b negative, c is negative. So I have a negative final solution.
Whoa.
So I need two numbers that multiply to get negative 15, but add together to get 2. How can I get two numbers that multiply to get a negative? Ooh. One has to be positive, one has to be negative. So I know one is going to be a positive solution, one's going to be a negative solution. Dylan?
Negative 2 and 5.
Negative 2 and 5. Let's see. So negative 2 times 5 will give you negative 10. Dominic?
5 and negative 3.
5 and negative 3. So 5 and negative 3. So 5 times negative 3 gives you negative 15. 5 plus negative 3 gives you 2. Good. Good. All right, let's look at the second one. Actually, sorry, we need to write the factor form. So this would be x plus 5, x minus 3. So I need two numbers that multiply to get negative 18, add together to get negative 7. Two numbers that multiply to get negative 18, add together to get negative 7.
Oh, it's 9 and 2.
9 and 2. What would it be? So 9 and 2, they add together to get 18, but how do they turn into negative 7? How can I change these signs to get it to be negative 7? I need a negative 9. So negative 9 plus negative, or plus positive 2 gives me 7. So here's a trick to memorize. Here's a trick to look for. If you notice that your C is negative, if that last term is negative, you know you're going to get a positive and a negative. You're going to have one positive, one negative. If your middle number is positive, your larger number you come up with will also be positive. If your middle number is negative, your larger number will also be negative. So that's a little pattern you can look for. Anytime you see C is negative, you know you're going to have one positive, one negative. And depending on what that middle number is, will depend on which one will be positive, which one will be negative. The larger number is always going to stick with that middle sign. And so in this case, 5 was positive, that one was negative. So we ran into 3 situations, 3 sort of patterns. If all your numbers are positive, your B and C are positive, both your solutions are going to be positive. If B was negative, but C was positive, we have both negatives. And our last one is if C is negative, they're always going to be opposites. One's going to be positive, one's going to be negative. These are the 3 types of situations you're going to encounter. The 3 types of possibilities you can get for your solution. So if you remember these and you see one, that might make it quicker for you to come up with those factors. Other than that, you should still be able to come up with the factors, but this is an easy trick to help you know, oh, I know both my answers are going to be negative. I know both my answers are going to be positive. I know both of them, one's going to be positive, one's going to be negative. So this is a quick little, these are some tips that might be able to help you keep your eye open for some things that might help speed it along. Are you copying that down, Kelly? You copy it down, it's fine. No, I want you to have that first. How do we feel on this stuff so far? 1 to 10.
11.
11? Oh,
Let's
call
see
it
it
out.
square. Eight.
Alright. So, I want to see if you are factor masters.
No.
I want you to try to factor these 2 problems. See if you can come up with your factors.
Is this like a test to see what we're doing?
Are you a factor master?
Alright, Jody, we're thinking of 2 numbers that multiply to get negative 36, add together to get 9.
Eight for 6, but that's going to 9 to 3.
Say multiply to get negative 36, add together to get 9. But the thing is, it's negative 36. So in order to get
But
negative
so we're
36,
trying to find the X.
we're trying to you always have to write it as you write the 3 X. The last number goes on top. The middle number goes in. So it's a negative thing. In order to get 2 numbers that multiply to get a negative, one has to be a negative, one has to be a positive. So we know one of our answers is going to be neutral, one of our answers is going to be positive. And they have to add together to get 9. So we have to start thinking, what are some factors of 36? What are 2 numbers that multiply to get 36? 6 and 8 gives you 48. Because you have to make your factors. Where 36 are 8? Six and 6. If you combine 6 and 6, you get 9. We'll find any other factors. Any other 36 on 9 and 4. Alright, so 9 plus 4, or is there any way to combine 9 and 4 to get 12? 9 and 4, okay, 13. We're close, but not quite. 12 and 3. Can we combine 12 and 3 to get 9 somehow? 12 minus 3. That means 12 is the opposite. Plus 12.
Yeah.
You back up. So you can take it for the second one, yeah? So,
You don't know that? Yeah. 21. 7 and 3. Well, 7 and 3, that's it. 7 times. Are we supposed to get 21?
I'm really glad I'm not
all right. Let's quickly talk about these. All right. Two numbers that multiply to get negative 36, add to get 9. Negative 36 and 9. C is negative, so we can think, oh, I know my solution, one has to be positive, one has to be negative. So what did we come up with for two solutions?
12 and
12 and 3. So positive 12 and negative 3. Good.
Oh, what the heck, bro?
All right. Looking at that second one, I need two numbers that multiply to get negative 21 and add together to get negative 4. I know once again, one needs to be positive, one needs to be negative. What are some factors of 21? 7 and 3. Which one's going to be positive? Which one's going to be negative, though? 7's going to be negative. 3's going to be positive. So x plus 3, x minus 7. 7. There we go. And those are your factors. We're going to continue this more tomorrow. Continue to practice this, sort of nail this down a little bit, and we'll expand on it more next week as well. We'll have a lot of practice before next Friday.